Hi there. This video is an exam paper walkthrough of the Eduqas GCSE Mathematics Higher Tier Component 2 paper from summer 2023. This paper is worth 120 marks in total, and this is the first video of 6. It will focus on questions 1 to 4, which account for 20 of these marks. Eduqas Component 2 papers are calculator papers, so a calculator should be used. A little disclaimer: there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 1. So at the top we've got use pressure equals force in newtons divided by area in centimetres squared. And we've got a picture of a filing cabinet here. The base of a filing cabinet is a rectangle. So the base is a rectangle. It measures 45 centimetres by 60 centimetres. The whole of the base is in contact with the horizontal ground. This is important when we're dealing with pressure, force and area. Part A. The empty filing cabinet exerts a force of 675 newtons on the ground. So we've got a force of 675 newtons. What is the pressure exerted on the ground by the empty filing cabinet? So we're dealing with empty here. Look guys, give your answer in newtons per centimetre squared. So we're going to use our pressure, force and area formula that they've very kindly given us. So pressure equals force divided by area. Now we've been given our force and we're trying to work out our pressure. So pressure equals our force of 675 newtons divided by our area. Now the area is the area that's making contact with the surface. So the whole base of this filing cabinet is in contact with the horizontal ground. So this part here, and it measures 45 centimetres by 60 centimetres. So we're going to find the area of the base. So the area is equal to 45 times by 60. Calculator paper, remember, so I'm going to do that on my calculator. 45 times by 60, so that's 2,700 centimetres squared. So that area now is going to go where the area would be in the pressure formula. So now to find the pressure, we're just going to simply carry out this calculation. So 675 divided by 2,700, which is 1/4, which is 0.25 newtons per centimetre squared. Part B. When the filing cabinet is full, so we're not talking about an empty filing cabinet now, the pressure it exerts on the ground is 0.75 newtons centimetres squared. So this is a full filing cabinet now, which is why the pressure is different to what we've just calculated. What is the force that the full filing cabinet exerts on the ground? Give your answer in newtons. Okay, so again we're going to use our force, pressure, force, area formula. So pressure is force divided by area. This time we know the pressure is 0.75, so let's substitute that in. All right, we're looking for the force and we know the area. It's the same area that we were working with before because it's the same filing cabinet. So now to find the force, we need to rearrange this formula. So force is going to be pressure multiplied by area. So 0.75 multiplied by 2,700. Which is 2,025 newtons. Question 2. The diagram shows information about the percentage of households in Eduvale that owned a desktop computer for the even-numbered years from 2006 to 2018. So we've got our even-numbered years, we've got the percentage of households that owned a desktop computer. Okay, so that's like a PC or something that you would have on a desk, so not a laptop or a tablet or anything like that. Part A, complete this statement. The percentage of households that owned a desktop computer decreased the most between the even-numbered years something and something. So we're looking for the biggest decrease, okay? That's the important thing here. It's a decrease, not an increase, it's a decrease. So let's look at the points that decrease. Well, from 2006, the percentage of households on a desktop is just steadily rising. It's only when we get to 2014 that it starts to drop. So we're going to investigate this area of the graph because this is the decrease. So from 2014 to 2016, we go from roughly 88% to 75%. So let's just make a note of that. 88% to 75%. So that's a 13% drop. Let's just double check this one. This one's going from 75% to 72%. That's definitely a smaller drop in the percentage of households. So we're going to say it's between 2014 and 2016. Okay, 2A part 2. Jane says the graph shows that 70% of people owned a desktop computer in 2009 because it passes through that point. Is Jane correct? Yes or no? We have to explain how we decide, so I'm not just going to tick one of these just yet. I'm going to take a look back at that graph that we were working with. So Jane says 70% of people owned a desktop computer in 2009 because it passes through that point. So we're looking at 2009, which would be here in the middle. And if we go up, she's right. 2009, the year, does pass through that point, 70%. However, we have no data for 2009. We've only plotted the data for the even years. So, and the lines that join up these points don't really have a value. Okay, they're just showing us the trend of the data. So that's what I'm going to say. I'm going to say that Jane is not correct because there is no data for 2009. The lines that join the points have no values. Okay, so something around the fact that there's no data for that particular year, so we can't say either way. But also those lines are just giving us the trend of the data. It's not like we've plotted every month or every day of 2008 to 2009, etc. If we'd have done that, we'd have continuous data and we'd probably be able to read it off a bit more accurately. Okay, part B. The table shows information about the percentage of households in Eduvale that had an internet connection for the even numbered years from 2006 to 2018. So this is working with internet connection now. On the diagram on page 4, plot the information for internet connection. So we're going to have to bring our graph back and we're going to plot this information. So in 2006, there was 45% of households that had an internet connection. So we're going to go across to 2006 and then up to 45. So 2006 is here, up to 45 would take us to here. 2008 up to 53. So 2008, 50, 1, 2. My eyes aren't working very well today, guys. 3. 2010 to 66. So 2010, 65, 66. 2012 to 79. So 2012, so 79 is there. 2014 to 84. 1, 2, 3, 4. 2016 to 88. 5, 6, 7, 8. And 2018 to 89. So 2018 up to 89. And then we're going to draw lines between those points, just like we've got for the desktop computer ownership. Now, I'm doing this in pen because I want you to be able to see it nice and clearly on the video. I would recommend you do this in pencil. So then if you do make a mistake, it's easy to rub out and there's not lots of random lines and points to confuse the examiner when they're trying to see if you've plotted the correct ones. Okay, so that is part 1 of B. So we've plotted the percentage of households that have an internet connection. Okay, part 2. In which even-numbered year was the difference in the percentage of households in Eduvale owning a desktop computer and the percentage of households having an internet connection the greatest? Okay, so we're looking here, back on our graph, we're looking for the greatest difference between the 2 points that are plotted for each year, remembering that pink is our internet connection and the black is our desktop ownership. So 45 to 55, that's 10. 53 to 62, 9. So these are pretty small jumps. I think it's going to be potentially one of these two because they look bigger. So this one, or this one. So let's just check. So this is 66 and 78. So this is 12. So this is 75 and 88. So that is 13. And this is 72 and 89. So I think this is definitely our biggest, which is 17. So the year that they had the biggest difference is 2018. Part 3. Eduvale is a large town in a county. Comment on how in this county the percentage of households owning a desktop computer and the percentage of households having an internet connection are likely to have changed in this period. So there's nothing really maths wise you can do for this, guys. It's just commenting on what you know about desktop ownership and internet. So we're thinking about our common sense here and the years that we're looking at. So we're working from 2006 to 2018. Okay, so the number of households, the percentage of households that have an internet connection is just going to increase over that time, isn't it? Okay, because more and more people have had the internet over the years and more people are going to continue to get the internet. So I'm going to start by saying the percentage of households with an internet connection would increase. Okay, so we've talked about the internet connection. Now I'm going to talk about the desktop computer ownership. So remember I said a desktop computer is a PC or a Mac. Okay, you know, one that sits on my desk, quite cumbersome, quite big. And over the years from 2006 to 2018, lots of new devices have come out. Laptops, tablets, those kind of things. So actually, it's likely that the percentage of households that own a desktop computer would decrease. So the internet connection would increase, but owning a desktop computer, not a laptop or a tablet or whatever, is potentially going to decrease. So I'm going to add that on. So the percentage of households with an internet connection would increase, but the households with a desktop computer could, we're not going to say definitely, but could decrease. It seems likely, doesn't it, with all the new devices that have come out over the last, 20 years or whatever. Eric is carrying out a survey for a company that makes energy drinks Pop and Whiz. He asked 200 randomly selected adults to complete his survey. Pop costs £1 per bottle. As part of his survey, Eric wants to find out how much money each month adults spend on Pop. In the box below, write a suitable question for his survey. To collect this information, you must include response boxes. Okay, so the important things about questions for surveys, we definitely need to give them a time frame. We can't just say, how many bottles of Pop do you buy? Because that's an open-end question, isn't it? So we need to give them a time frame. So I'm going to say, how much money do you spend on Pop in a month? Okay. So we've given them a time frame. We've asked them specifically how much money do they spend on pop in a month, and that month is giving them a time frame rather than it being open-ended. Now we need to give some response boxes. The important thing about the response boxes is that they don't overlap. Okay? Now the good thing about this question is it's £1 per bottle. So we're not going to be spending £1.50 or £1.42 or £2.30 or anything like that. So we don't have to, the overlap is a little bit easier on this one. So first of all, we need an option for nothing. Some people might not buy pop. Okay, so we need to put that in there. And then we need a couple of different response boxes. So let's go for £1 to £3 spent in a month, £4 to £6 spent in a month, and then let's go more than £6 spent in a month. We don't need to do an exhaustive list of the potential values, but this is for anyone that hasn't spent anything on pop in a month. This is for anyone that spends more than £6 on pop in a month, and then obviously got these two categories here as well. Okay, part B. In another question, he asks the 200 adults how many bottles of whiz they buy each month. And the table shows the results for these 200 adults. So these are their ages, these are the number of bottles that they buy, and here's the frequencies. Find the probability that an adult chosen at random from these 200, so chosen at random from the 200, from the total population, does not buy whiz. Okay, so the total population is 200, so I'm going to pop that straight on the bottom of my fraction. But we're looking for people that do not buy whiz, so we're looking for this column here, the 0 column. So let's total that up. We don't have any particular age to look at, we're just looking at this cohort in total. So 26 plus 29 plus 32 is 87. So I'm going to put 87 on the top there. And that's my probability that they don't buy whiz. Okay. Part 2. We're looking at the probability that an adult chosen at random from these 200 is 26 to 35 years old and buys 5 or more bottles of whiz each month. So we're looking at the 26 to 35 year old section, which is the middle row, but we're looking also for 5 or more bottles of whiz a month. So it's going to be the 5 to 10 and the more than 10. Okay, so again, 41 plus 2 is 43. The total population is still out of the 200, but it's 43 out of 200 that are 26 to 35 years old and buy 5 or more bottles each month. 4A. The diagram shows a circle inside a square of side 8.2 centimetres. So that's our diagram here. We've got the circle, we're inside a square, and the square's got sides of 8.2 centimetres. The sides of the square are tangents to the circle. So that tells us that they don't cut through the circle, but they lie flush against the circle. So they just touch it slightly at a point. They want us to find the area of the shaded region, and we've got to show all of our working out. So when we're finding the area of a shaded region, we have to find the area of the whole shape, and then the area of the shape that's not shaded, and then subtract them from each other. So I'm going to start by finding the area of the square. Now, they helpfully tell us that the sides are 8.2 centimetres. All the sides on a square are equal, remember. So we're to find the area of the square, we're going to do 8.2 multiplied by 8.2. So that's 67.24 centimetres squared. Now we're going to find the area of the circle. Okay, and the area of a circle is pi times radius squared. Now, we need to find the radius. Now, the important thing here is they've told us that tangents, the sides of the square are tangents to the circle. So we can also say that those sides of the square are the diameter of the circle. So if the diameter is 8.2, we need the radius for the area. So the radius is half of that, which is 4.1. So the area of the circle is pi times 4.1 squared. So pi times 4.1 squared. So that gives us 52.81017. Notice that I'm not rounding, because if I round I could potentially get an error in my answer when I'm continuing to use these values because I haven't finished. Okay, so the area of the shaded region is the area of the square, the whole shape, subtract the area of the circle that's not shaded. So our area of the shaded region is 67.24, subtract the 52.8101721. Now notice I didn't delete that off my calculator because I don't want to enter all those decimals in again. So I'm just going to start by typing in 67.24, subtract, and then I'm going to press the answer button here. So that'll put my previous answer in, so I don't have to put all those decimals in. So that's 14.42982749. Okay, and that's centimetres squared because we're working with area. The question doesn't ask us to round at any point. You can if you want to, but I'm not going to. It doesn't ask me to. I'm just going to write down all of those decimals. Okay. Part B. So the diagram shows a parallelogram. The parallelogram is a cross section of a prism, so it's the cross section of a 3D shape. Okay, so we're working with a 3D shape here. So here's a parallelogram. We've got a base of 9.8, a perpendicular height of 7, and then that slanted side there is 8 centimetres. The length of the prism is 16 centimetres, and they want us to find the volume. So to find the volume of any prism, you find the area of the cross section, which in this case is our parallelogram, and then you multiply it by that length that gives it its 3D depth. So we want the area of the parallelogram, and then we're going to multiply it by that length of 16. So area of parallelogram. So the area of the parallelogram is base times the perpendicular height. So it's 9.8 times 7. We don't need this slanted side to find the area, so we're ignoring that, guys. 9.8 times the perpendicular height. So 9.8 multiplied by 7, which is 68.6 centimetres squared. So that's the area of the cross section. Now to find the volume of the prism, we need to multiply the area of the cross section by the length. So the volume is equal to 68.6 multiplied by 16. I didn't delete my answer, so I can just press multiply. It'll bring my previous answer, 16, and then that gives us 1097.6, but it's centimetres cubed this time because we're working with volume.